Ya, oke. Bismillahirrahmanirrahim. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And welcome back to our basic physics class. And today we are going to learn about a new topic. But actually, this is not a very new topic because today's topic will be correlated with what we have learned in our previous meeting. And today we are going to learn about something called free falling object. And the concept of free falling object actually similar with the concept of velocity and acceleration. I want to remind you that in our previous meeting, we have three quantities. We have three quantities that are very correlated with the movement of object. The first one is displacement, and the symbol is x, and then the unit is meter. And then the second one is velocity or v, and the unit is meter per second, and then the last one is acceleration. And the symbol is small a, and the unit is meter per second square, or meter per second powered by 2, and this concept, so this concept, applied in horizontal plane, so that's why, in our previous video, we always use example of horizontal plane. Let's say this is a car, and the car is moving, from point A to point B, and the plane, is in horizontal form, so this is the horizontal. So that's why we use displacement and etc. But in this case, in free falling object, the plane is not horizontal. Instead, we use a vertical path, or vertical plane. Because because if we say falling, if we talk about if we are talking about falling, it means that the object moves in a vertical path. So the movement will be like this, because falling means the object will move to the center of the earth. So let's say you have apple here. So this is apple, and the apple fall. The apple is falling. Falling toward the earth. Or to the earth. So this the project, the plan, the path is in vertical. So vertical path. And actually, the concept of horizontal and vertical is similar, and we are going to use this one. But this concept, is only applied in in horizontal path. Yeah, so these equations. Yeah, so far we have 3 equations. Yeah, 1, 2, and 3. Yeah, and we are going to convert. Yeah, from this one, which is horizontal, to vertical. Yeah. Okay, so our job in this video, so actually we have some videos for this topic, and this will be the first one. Yeah. Okay, so I will copy this one. Yeah, so yeah, so yeah, the first one. Yeah, first equation. Okay, so the first equation, yeah, we have Vx equals Vox plus Ax t. Yeah, and this is for the horizontal. Yeah, and what will happen if we convert this one into the vertical? Yeah, so in this way, yeah, as you can see, we have x here. We have x here. We have x. Yeah. This x, yeah, indicates that this equation happens on horizontal plane. Yeah. And if we want to make this equation become applicable in vertical path, so we have to change every x into y. So if we change it, then we have Vy. Okay, so Vy equals Voy plus, in this case, we do not use this, but we use G. Yeah, so G is gravitational acceleration. Yeah, and then T. Okay, so Vy is a final velocity of object. Yeah, and the unit is meter per second. Yeah, and then Voy is initial. Yeah, initial velocity of object. Yeah, and it's also meter per second. And then G is gravitational acceleration. Yeah, meter per second square. Yeah, and then T is time. Yeah, or the duration. Or the duration of falling object. Yeah, of falling object. Second. Yeah. Okay. Now I will give you some example. Yeah. To show how to use these equations. Yeah. Okay. And then I will move myself here. Yeah. Okay. Let's say, yeah. Let's say I have a tall building here. Oh no. Okay. Let's say I have apple here. So this is the apple. Sorry for bad drawing, yeah. And then this is the ground, yeah. This is ground, yeah. And then I want to release the apple, yeah, from this point into the ground, yeah. If I release my hand, let's say I grab the apple, yeah, and then I release it. So logically, the apple will move down, yeah, or fall, yeah, or falling into the ground, yeah. So this will be the path of falling apple, yeah. Nah, I just want to know, yeah, I just want to know. Just before, yeah, just before the apple, yeah, so this is the apple, just before the apple hit the ground, yeah, so the apple is not, I mean, the apple does not hit the ground, but just about to hit the ground, yeah. So if we zoom, yeah, if we zoom this this picture, so let me zoom it. Nah, there is space here. There is small space here. So this is small space, yeah, between the apple and the ground. So it means that the apple does not hit the ground, but it's just about to hit the ground, yeah. Because if the apple hit the ground, yeah, the velocity must be 0, yeah, because it's hit, yeah, because it hits the ground. But in this case, yeah, the apple is just about, yeah, just about hitting the ground, yeah. So there is small gap, yeah, or small space between the ground and the apple, yeah. Yeah. So I just want to know, yeah, how much, yeah, how much the velocity of apple just before hitting the ground. Yeah. So this is the imagination, yeah, I mean the example of this concept, yeah, especially for equation number 1, yeah. Okay, so by looking this kind of example, yeah, we can just interpret, yeah, we can just interpret that in the initial position, yeah, before I release my hand, I mean before I release the apple, the velocity of apple is 0, right? Yeah. So this means that the v oy of the apple is 0, yeah, because it is static, yeah, not any movement, yeah. And it will be different if we give some if we push, yeah, the apple into the ground. But in this case, I just hold the apple without any further movement, and then I just open up my hand, so the apple will release from my hand, yeah. So the initial velocity of the apple is 0, yeah, 0 meter per second, yeah. And then the time or the duration, yeah, of the apple from its initial position to the final position, let's say the duration of the falling body is 2 seconds, yeah. I just pick any random number, yeah. So you can just 3 or just follow what actually you can just make it using experiment. Yeah, you make certain object falling, then before hitting the ground, you stop the stopwatch. Yeah, so you can know the duration of the falling body. But in this case, let's say the time to reach, I mean the time for the object, yeah, from its initial position to the final position, it's at least 2 seconds. Yeah. And then the gravitational acceleration is 9.81 meter per second square. Yeah. In some books, yeah, some people say that the gravitational acceleration is 10, yeah, or some people say 9.8 or 9.81. But it's okay. You can just follow the instructions, yeah. And if not any specific instruction of how much the gravitational acceleration, you can just use this number, yeah, 9.81. And this is similar with every places in the earth. Yeah. So this is the earth gravitational acceleration. Yeah. And this number will be different if we go to Mars or go to Moon. Yeah. So this will be only happen. This will only happen in the earth. Yeah. Yeah. So this earth. Okay. Yeah. So let's find this this equation. Yeah. And because we talk about the velocity of apple just before hitting the ground, yeah, so the variable that we want to know is the value of Vy. Yeah. So this variable, yeah, this variable that we want to know the value. Yeah. Okay. Now we can just use, yeah, this. We can just use this concept. Yeah. Okay. So Vy equals to Voy plus Gt. Yeah. Okay. So because we want to find this one, so yeah. Okay. The value of Voy is 0. Yeah. So this 0. So we just put it 0 here. So this 0 plus G. And the value of G is 9.81. 9.81, and then times the duration. We have 2 seconds here. Yeah. Okay, so we put number 2 here. Okay, so yep, we have our answer. So at the moment, I just use my calculator. 2 times 9.81. Okay, so I got 19.62 meter. Yeah. Meter. Yeah, meter per second. So this is the value of final velocity of the apple just before hitting the ground. Yeah. Okay, now I just want to give you another example, but in this case, we change the direction of the body of the apple. So the apple is not moving down, but it will move up. Yeah, it will move up. Yeah. Okay, so let me use another page. Okay, so let's say this is me, and I grab the apple. Yeah, so this is the apple. Yeah, and then this is the ground. Yeah, and then yeah, I throw, I throw the apple for moving up vertically. So this will be the path of the apple, the thrown apple. And logically, the apple will not move at certain point, because the effect of gravitational acceleration. So after I throw the apple vertically, then in certain point the apple will be stop and reach the highest point of just reach the highest point. So let's say the highest point will be in here. So this is the final position of the apple. And because the apple moves without in the direction of gravitational acceleration. So the direction of gravitational acceleration is moving down. So this is gravitational acceleration. So the direction of gravitational acceleration is moving down, but in this case, I throw the apple, so the direction of the apple will be opposite, with the gravitational acceleration. So I have to give the initial velocity. So this velocity, is not zero, because if it is if the initial velocity is zero, my apple will be not moving up. Instead, it will moving down, or fall, or falling. So I have to put a certain value of initial velocity. So this will be, let's say, I will give it like 3 meter per second. And in this and in this position, because it will reach the highest point, so it means that the object will stop. Will stop. Will stop, and just before the apple moves down, so the final velocity of the apple will be zero. Because wait a moment. Because let's say this is the apple, so I will throw the apple moving up, then at a certain point it will reach the highest point and it will stuck here. So the velocity will be zero just before the apple moving down, or just before the apple falls. Okay. And then for this case, I just want to know, how much the time, or how much the duration will be from the initial position of the apple until the apple reach the highest point. So this will be the question. Okay, so let's wait a moment. So let's use the first equation. So we have Vy equals to Voy plus GT. Okay, so the final the final velocity will be 0, yeah. Okay, so I will write this 0, and then the initial velocity will be 3 meter per second, yeah. So I will write it here, 3 plus, nah, the gravitational acceleration, yeah, we use 9.81 meter per second. But in this case, yeah, because the direction of the apple is opposite with the direction of gravitational acceleration, yeah, I throw the apple moving up, yeah. But in the same situation, the gravitational acceleration, yeah, the direction of gravitational acceleration is moving down. So my apple is in opposite direction. So in this case, I have to put sign negative, yeah, on the g. So the g is not just 9.81, but the g will be minus 9.81. Yeah. Okay. And then plus times t. Yeah. The t is what we are going to find. Yeah. Okay. So the t 3 will be minus 3, and then this will be minus 9.81 t. Yeah. Okay. So the value of t will be minus 3 divided by minus 9.81. Yeah. Okay. So to show a good result here of this case, I will move the t into right position, and this one will be in the the t will be in the left, yeah, the t will be in the left, and this one will be in the right, yeah. Okay, so 3 divided minus 9.81, yeah. So the t will be, okay, so I will use my calculator again. 3 divided by 9.81. So it will be 0.3 second. Yeah. Okay. Yeah, 0.3. It is very short time. Yeah. Actually, I have to find another value. Yeah, for the initial velocity, but it's okay. It's just number. So the logical way to find the duration of the apple until it reach the highest position, yeah, is this one. Yeah. So we use the first equation, yeah, what we have. Yeah. Okay, so that's for the first video. So after this, I'm going to tell you about any other equations. Yeah. So please do not just stop in this video, because we have another video after this.